So let's take a look at functions. Some of this will be a review. Actually, most of it should be a review, but a little bit of it may be a little unfamiliar, so we'll take a look and explain a few things here. Let's start off with one of these machines you probably had back in middle school. And you put something in, you get something out, and that's how a function works. What we usually do is have an idea of what we want to get out of a function and know what the function does, and we get to choose what we put in to get the expected thing out. That's kind of how a lot of science and math works. So a couple definitions from functions we need to make sure we're good at. First up is, what is domain? And your instinct might be able to say it's just x values, but it's really more about what you're putting into the function, your input values. So I can put up here that, yeah, it is x values, but really more importantly, it's the input. Okay? It's a set of all the x values you can plug into this function, and you get something out. Your range values, again, you might think y values, which is true generally for a function, but it's more about the output. It's what you're getting out when you've put an x value in. So I will put up there, it is a y value, but it's more about the output you're going to get. Okay. And broadly, a range is all of the y values that you're going to get out for any x you could possibly put in. And we'll keep looking at that as we go through this deeper. So again, the whole idea of input, output, and just kind of bring back up something from the last lesson. A lot of this stuff comes down to the slope, some rate of change. And its slope is y over x. So the input, this is how much I'm getting paid. The input is the hours I'm putting in. The output is the amount of money I'm going to get paid. So the input, for any time you have slope, the input is the bottom number, the x value. The top number is your output. So let's take a look at piecewise functions. And hopefully this is somewhat familiar, but I know that a lot of times it's a little shaky, so we'll go through it. So you're asked to find f of 3. Okay, and I know you're probably familiar with algebra. You take 3 and plug it in for x. The trick here is you have two functions. And if you put 3 in both of these functions, it's no longer a function. You'll have an output here and an output here. We can't have two outputs in the same spot. That's not a function. It breaks the rule. Think vertical line test. So I've got to look at the domain restrictions, and that's these things over here. If I'm looking for 3 to plug in for x, I got to look what rule it fits into. Well, is 3 less than 1? No. So I'm not using that one. So if I put in 3 for x here, 3 is bigger than 1, so I'm going to go with the negative 3 times x option. So negative 3 times 3 plugged in for x here is negative 9. So f of 3 is negative 9. When I put in x as a domain value, I get negative 9 out as a range value. So 3, negative 9. And that would be the single point. So if I want to graph this entire function, then I've got two parts to it, and generally they're going to kind of be disconnected. There's a chance they might come together at some place, but don't expect that. Don't be surprised if it's a line here and another line up here somewhere. That's pretty normal. So 2x plus 5, but only for x values that are less than 1. Not including 1, just less than 1. So, all right, 1's here and less than's going back this way. I'm going to just graph this as a typical line. I'm just going to stop once I get there. So my intercept's at 5. My slope is 2. So I'm just going to put a few points on here. And when I get to 1 for x, I'm done. So I would have kept going up 2 over 1 for a while. But that's where I stop. And it's not equal to 1, so that's an open circle right there. Okay. But it does go on back. Everything, looks like I might have got that dot off just a little bit there. It's everything from 1 and back to the left. Okay. And just to make it kind of stand out, I'll do this one in a different color. So if x is anything equal to 1 or greater, then I'm looking at the line negative 3x. Now, if I'm doing something where the intercept won't actually show up on the final graph, I usually go ahead and graph the line like I normally would have, but I just kind of do it lightly in pencil so I can erase the points I don't need. So let me just do that and I'll show you what I mean. So negative 3x, that would have an intercept at 0, and you would go down 3 over 1 from there on. Okay. Well, nothing that's back this way is going to show up on this graph, only points from 1 and onward. So the line would look like that, and I'm going to go back and erase this point at the origin, because that shouldn't be included on my final graph. And that would do it. That's your piecewise function. You've got 2x plus 5, that line stopping at 1 and not including 1. And you've got negative 3x, but only for x values from 1 and greater. Okay? And if you're trying to get the range for this function, you've already been given the domain. If you're trying to find the range, then your range would be, well, let's see, I've got 7, or almost 7 for a y value here. I've definitely got all kinds of y values less than 7. I don't see any breaks in the graph from here on down. I'm kind of double covered over here. I've got the same y values that are going to show up over here. So I'll never have 7. I'll never have anything bigger than 7. But I will have any number you could ever imagine, including every decimal and fraction that you could ever come up with that's less than 7. So y is less than 7 would be my range. Not equal to, because we've got an open circle right there. And let's look at some ranges and domains that might be kind of tricky to calculate. Eventually you need to do this without a calculator. If you need to put this in a calculator or put it in Desmos for now to get started, I encourage that. Put it in there, get a feel for what it looks like, then work on doing the algebra so you can do this without a calculator. But in calculus, you have to be able to do this without a calculator, so start getting used to that. All right, so I've got this function. It's a square root, and it's x squared minus 9. That's going to turn out to be a circle, but if you don't know that right off, then you might want to graph it, just kind of see what it looks like, or just do the algebra and see what it turns out to be. So we've got to think about what x values can I not plug in. A good rule of thumb for a domain that I like to think of is can it be everything? Can it be all real numbers? Until you find any value that it can't be. So let's think about what our restrictions might be here. We're taking the square root. Can I take the square root of 0? Sometimes people tell me they can't. You can't. Square root of 0 is 0. That's okay. 0 times 0 is 0, so that checks out. But when I take the square root of a negative, I'm no longer in the real number system, and our numbers that aren't real don't show up on these graphs. Let's keep it there for now. Yes, there's some complex numbers out there. We will get into those. But for now, we're going to think of this thing as being on our normal XY coordinate plane. Only real numbers live there. So anything that comes out to be not real won't show up on that grid. That's the simplest way to keep it, or think about it. So think about things you can't do. I can't take the square root of a negative number. So whatever is under here I've taken the square root of, it has to be greater than 0. But it could be equal to 0, so at least has to be 0. Okay? And this is going to lead to kind of an interesting result, because if I just go through this either factoring or solving for x, and I'm going to do this in red and erase it because I'm going to get to we get stuck here in a second if I don't do this a certain way. So let's just add 9, take a square root of both sides. So x would be greater than or equal to, and then don't forget that when you take the square root, it could be plus or minus. If you need help understanding that, I can run through that with you too. Well, this doesn't make a lot of sense. X is anything, I put it on a number line. X is anything bigger than negative 3, or also bigger than 3. So usually when they're going kind of the same direction, something's up, you need to check into it a little bit more. So here's what we're going to do. Let's go ahead and factor this thing. I think that's probably the best place to start. So x minus 3x plus 3 would be my two factors. Each one of those are going to get set equal to 0. Okay. Eventually we're going to prove why that's something you do in algebra. It's called the fundamental theorem of algebra, so it's pretty important. But for now, I'm just going to kind of leave it at, hey, you've been doing this, keep doing it. We're going to have x is greater than or equal to 3, x is greater than or equal to negative 3. All right, but here's where we said something weird's kind of going on. So what I need you to do is let's make a number line. And let's think about these two values, 3 and negative 3. We're going to call them critical values, and we're going to check what happens if I plug numbers around these values into my function. So I'm going to pick something smaller than this, something between the two numbers, and something bigger than 3. I'm going to plug those into functions, see what happens. Remember, x are number, the domain is numbers you put in, range are numbers you get out. And if you can't put an x value in and get a number out, that's not part of your domain or your range. So let's see what happens if I pick something smaller than negative 3, like negative 5. I usually pick 0 if I can, or multiples of 5, multiples of 10. Those are usually pretty easy. So suppose I pick negative 5. I'm picking that at random. You can pick any number smaller than negative 3, but plug it in for x and see what happens. So if I do that, negative 5 squared minus 9, well, negative 5 squared is positive 25, and that's going to come out to be square root of 16. So plus or minus 4. That's okay. I can get two values out, and that's okay. The point is, if I pick something smaller than negative 3, it checks out. It works. Okay. So let's try something in between. I've kind of got a feeling it's probably not going to work. 0 is a good one. It's right in the middle. If I put in 0 for x right here, and 0 squared minus 9, that would be the square root of negative 9. Well, it's not. I'm going to stop there. It's not real. Square root of a negative, you get into complex numbers. It's not real. So it's not going to show up on a coordinate plane. It's not going to show up on a number line. So numbers that are in between negative 3 and 3, they're not going to show up on here. And a real quick, easy way to check something bigger than 3, let's just pick the positive version, whatever I picked over here. Say I try 5. Well, 5 squared is also 25. It's going to end up being the exact same math. So anything bigger than 3, that's going to work. You can plug that x value in, and you do get a y value out. That's the test. If you plug an x value in, do you get a y value out? And that's what's going on in the middle here. Pick any number you want between negative 3 and 3. When you plug it in here and square it, it's not going to be bigger than 9. You're going to be taking the square root of some negative number. So for any x value between negative 3 and 3 you plug in, you can't get a y value out. That's not going to be part of your domain, and those outputs are not going to be part of your range. So for now, I'm just focusing on domain. And your domain at the end here, x would be less than or equal to negative 3. These were equal to also, or if you're not sure, just plug in negative 3 and see what happens. You'd end up with square root of 0, which is 0, that's okay. The other part of your domain is positive 3. Anything that's 3 or greater. We have one final step left, and that's now to find our range. We've got the domain being numbers from negative 3 and back, and from positive 3 and forward this way. So we're not going to see anything in between negative 3 and 3. Nothing's going to show up in there. There's no point in plugging in x values because you already know you won't get a y value out. So let's try plugging these numbers in and see what happens. If I put in 3 for x, well, 3 squared is 9. 9 minus 9 is 0. So if I plug in 3, I get 0. And same thing if I plug in negative 3. Negative 3 squared is 9. 9 minus 9 is 0. So I get 0. Okay? You can do as many of these as you need to until you get the idea of the shape. Most of the ones in the homework are either going to be circles where you're looking at circle in between the 2 points that outline your domain, or they're going to be hyperbolas that kind of go out like this. And this one's going to be a hyperbola. We'll see it kind of take shape in just a second. Most of the time you can kind of tell because the way the arrows are going. If the domain's showing, if you graphed on a number line and they're going apart, typically it's going to be a hyperbola for our examples. And if they're going toward each other, it's going to be a circle. That's not always the case for all functions, so I don't really want to make that a blanket statement. But for this particular homework, that's generally going to be the case. So let's try a few more points, just get a sense of where they are. and then we should see this thing start taking shape. We tried 5 a few minutes ago, okay? If I put in 5 for x, then 5 squared minus 9 came out to be plus or minus 4, okay? We had to work a few minutes ago. So if I put in 5, I get plus or minus 4. And similarly, if I plug in negative 5, it's going to be the same thing. So if I put in negative 5, I get positive and minus 4. Okay? You do get the plus or minus, so you do get both of those y values. That is important. And just to see, I'm going to try 10. If I put in 10 for x, what do I get on the y? Well, put in 10 for x, you get 10 squared minus 9. Square root of that. So 100 minus 9, well, that'd be 91. 10 squared is 100, 9 squared is 81. So this is somewhere around 9.5. Okay, so I'm just going to do a little squiggly, say about, plus or minus 9.5. And we could get more precise, but that's good enough for now. So if I put in 10, plus or minus 9.5 roughly, put in negative 10, plus or minus 9.5 roughly. And we can kind of see this thing taking shape now. So this is going to turn out to be a hyperbola. And really now just the thing to think about is, make sure, assume that it's all real numbers unless you have a reason to think otherwise. So if I'm looking at the y values that will be included, if I was trying to list out every y value, which is a futile effort because there's an infinite number of them, but if I try to list out every y value that ever shows up, well, it looks like everything kind of in the middle area of the graph is covered, so let's look at the ends. Well, hyperbolas slowly go up forever, they slowly go down forever. Same thing on this side. This will be in all real numbers for your range, because all y values you could ever imagine will show up somewhere on this graph. So to finish up for range, I'm just going to say all real numbers. We'll come up with some interesting ways to express all real numbers throughout the year. For now, I'm just going to say all real numbers. And lastly, normally in class, I'd kind of give you a few minutes to take a look at 17 and 19. We will definitely have discussion about those in the next lesson. I do kind of anticipate questions. Try them, see if you can figure out what's going on. They're almost going to look like the same problem, but there's a subtle difference, and it's actually a pretty important difference. And for sure, we'll talk about that in the next lesson.